Hello, in this video I'll be going over some inclined planes problems. You might see many of these in a physics class or a basic mechanics class. In this video I'll just be going over basically blocks rolling down slopes or a ball or pretty much just objects going down. There'll be no pulleys in this video, but there will be friction problems. Alright, so basically an inclined plane, it looks like this pretty much. So you have an angle here, angle of elevation, and you have a block or an object on it. Now this object, it's on Earth, so it's going to experience a force of gravity going straight down. So I'm just going to say F of G as a subscript. And basically the reason it falls down the slope is due to its vector components. So this, basically using mathematics, this angle here is going to be this angle in here. We don't need to prove that in a class. So there's going to be a force going down the slope, and there's going to be a force perpendicular to the surface known as the normal force. So just drawing that in, it's going to be going up like that and across like this. So you can see that force is that one there, and this force is that one there. Right, so basically that's the basic premise of inclined planes. So you have basically you have an object with a certain mass and it exerts a force down, and its vector components is the reason it falls down the slope. You could also have a force pulling it up, or a force of friction. So the force of friction is the friction coefficient times the normal force. So let's say if you want to find the net acceleration, you'd need to find the net acceleration would be the sum of the forces down the slope divided by the mass, and the sum of the forces would be equal to all the forces in basically down the slope. So it would be the force of x minus the force of f, because they're going in opposite directions. And if the sum of the forces down the slope is in equilibrium or zero, it will basically be staying still. So that means the force of going down the slope will be equal to the force of friction, or any force pulling it up the slope. Alright, so that's the basic premise of inclined planes. I feel like you can, it's easier to understand once I give you a problem. So we're just going to do that right now. And I'm just going to pretty much rub this out and keep that diagram for you guys. So I'm just going to move this diagram here. Right, so our first question is, if we have an object is placed, actually I'm going to rub all this out so you can like really think about it. So I'm just going to leave the triangle, but I'm going to draw the components in later. So let's say we have a block and it's on an incline of, let's say 25 degrees, and it exerts a force down. Its force down, so F of G, is 400 newtons, and it has a friction, and the surface it's rolling down has a friction coefficient of 0.19. Find the net acceleration down the slope. So if you haven't got the problem, feel free to pause the video now and have a go. Alright, so we'll draw in our components. So we have Fg, force of gravity going straight down, and we have its vector component. So F of G is the hypotenuse of this triangle in here. F of x, F of n, and 25 degrees here. So F of x is equal to F of G sine of theta. So in this particular case, F of x is equal to 400 newtons sine of 25 degrees. So just calculating that in our calculator, we're going to go 400 sine of 25. Make sure your calculator is in degrees, and we're going to get 169.047 newtons. Just rounding that, I'm going to go 169. No, not 0.5. That's way too. That's just wrong. 0.5 newtons. All right. And I'm just going to draw the forces in here again. And we have a force of friction as well. So to find our force of friction is the friction coefficient times the force of the normal. So the force of the normal, I'm just going to move it over here. The force of the normal is going to be Fg cos of the angle. So F of n is going to be 400 cos of 25 degrees. Excuse me. 400. So it's going to be that, and it's going to be using our calculator. 400 cos 25. Oops. I'm going to get 362.52 newtons. Now this is not the force of friction, but if it was, the object would be going up the incline, because that force is a lot bigger than that force. But that's not our force of friction, that's our normal force. So if you were to put that as your force of friction, you'd get big fat X. But our force of friction is going to be 0.19 times this number here, so 362.52. So our force of friction, using our calculator, 362.52, is 68.87 newtons. And that's much more acceptable, because if you put something on any surface and it rolled down really smoothly, you obviously had a friction of 0. But if it takes its time, there's obviously some friction. And depending on the material, there'll be either strong friction or pretty weak friction. This is a pretty standard friction of most surfaces, because nothing has a friction coefficient of 0, really, because there's always going to be some amount of friction depending on the material. Alright, so we found all that, so I'm just going to make this a bit smaller so we have enough room for the rest of our information. So actually I'm just going to move that a bit higher as well. Righto, so now we need the sum of the forces down the slope. So we obviously have the force going down the slope, but we need to get minus the force of friction, because it's going in the opposite direction. So the sum of the forces down the slope is going to be equal to 169.05 minus 68.87. Therefore, the net force down the slope. So the reason I put sigma there is the sum of the forces down the slope. That's why the notation's there. So you're going to get approximately 100.11 newtons. Now, if your numbers aren't exactly the same, that's okay, because I'm doing a bit of rounding. Alright, so now that we've found that, so the acceleration down the slope is the sum of the forces down the slope divided by the mass. Now, at the start of the problem, we were given this number here. That's the force acting down due to gravity. We know that F equals ma. So force of G is going to be mass times the gravitational constant. Since we're on Earth, G is 9.8 meters per second squared. So we can find our mass really easily. So we go 400 newtons, I'm just going to leave the units off, equals some mass times 9.8. So to find the mass, you just divide by 9.8, put in our calculator. Our mass is approximately 40.82 kilos. Right, so now we have that. We put it in here to find our net acceleration. So you have 100.1 newtons over, actually I'm just going to leave the units off because it can get confusing if you didn't know what you're doing fully. And the mass is 40.082 kilos. So our acceleration down the slope is approximately 2.45 meters per second squared. Alright, that was a pretty tricky problem because I included friction. The next problem we'll be doing will be a bit easier than that. So I'm just going to rub this all out. You also might have to deal with equations of motion in some of these problems, because if you can find the acceleration down the slope, you can find the time it takes to go down if you're starting from rest or if you was given an initial velocity. But yeah, pretty much this is as hard as it gets for a basic physics class in the Queensland curriculum. You might have to do pulleys, but pulleys are pretty simple. It's the same principle pretty much as friction, because it's just a force going in the opposite direction as the force down the slope pretty much. Unless it was like pulling it up and it was a lot greater. So I'm just going to get rid of all these vector stuff. I draw them in each time because I think about the people that want to try the problems without many help. But I will draw in the vectors back in again to help with the understanding. So that's the basic mechanics of an incline plane. And I'm just going to change our angle. Alright, so for our next problem, so we're going to have Our object is going to have a mass of 200 grams. And we're going to have a friction coefficient of 0. And pretty much you just got to find the net acceleration down the slope. So I'm just going to make that. So if you want to have a go at the problem, feel free to pause the video now and have a go. Right, so same principle as before. You have a force of gravity acting down. Right, and this angle, oh, I haven't given you an angle. Let's say this angle is 35 degrees. And, yep, that's 35 degrees. So f of x equals fg sine theta, and f of n is fg cos theta. You don't really need the normal force in this particular problem, but it's always good to visualize what's happening. And I draw these arrows so I know the direction of the forces. So normal force, it goes up as well, and the force of x goes that way. So force of x, and that's the normal force. Right. 200 grams, we need to convert that to SI units. So SI units is meters per second, kilograms, etc. So 200 grams to kilos, you just divide that by 1,000 and they'll give you 0.2 kilos. So that's its actual mass. So a lot of students would get that wrong and just leave it as grams, and well, they get follow through error, but they wouldn't get full marks for it. Alright, force of gravity is just mass times the gravitational constant, which is 9.8 meters per second. So Fg is 0.2 times 9.8. Using our calculator, I wouldn't do this in your head, 1.96 newtons. So that's the force of gravity acting down on the object. So that's this force here, this vector here, if you're a bit lost. Okay, so we have no friction, so we don't really have to not worry about the normal force unless the question asks you to find the normal force. Alright, so f of x is going to be 1.96 sine of 35 degrees. Put that in our calculator and you should get 1.124 newtons. Right, now we've got to think about the problem. What is the sum of the forces down the slope? I'll give you a minute to think about it. Basically, so there's no, if we had friction, it would go up like there, right? It would be opposing the force down the slope. But we have a friction coefficient of 0. That means that's a smooth surface. So there's no force acting in the opposite direction to basically the object just rolling down. So pretty much the sum of the forces in the x direction is just f of x, which is this force here. So that's pretty easy to find. So because we already calculated it. So our acceleration is the sum of the forces in the x direction divided by the mass of the whole system. So it's going to be 1.124 divided by 0.2 kilos. And you should get 5.62 meters per second squared. Right. That was a lot easier than the other problem because it didn't deal with any friction. Now we're going to do a problem very similar to the first one. So, sorry I didn't give you the angle at the start either. Yeah, that's a pretty standard problem. I would say that would be a 3-mark question. If you got friction and equations of motion into it, you could probably pull it out to like an 8 or 7-mark question. Obviously. And if you had pulleys, you could probably make it a 10-mark question. But that's pretty standard, like, questions with basic mechanics. You could also do it, yeah, pretty much. Alright, I'm just going to get rid of the vector stuff. So we start it from scratch every time. And we could change the angle. Alright, so for our last problem, we're going to have an incline of 30 degrees. We're going to have a friction coefficient of 0.5. And we're going to have a mass of 10 kilos. So I'm just going to ask you to find the acceleration, the net acceleration of the block down the slope. So how much this block is accelerating that way, or that way, depending if the friction is bigger or not. but I think it's going to flow that way. Alright, so feel free to pause the video. Alright, so once again I'm going to draw in my vector components. F of g is our hypotenuse always. Make sure this vector is always the biggest. This one here. If it's not, you will get it wrong. Make sure that's the hypotenuse every time. Whoopsie daisy, I'll change my colours. So that's 30 degrees. F of x. I put these arrows in to show the direction of the forces. And F up. And F down. And we're going to have a force of friction. So we know our force of friction is the friction coefficient times the normal force. So we're going to need to find our normal force. First off, force of gravity is mass times gravitational constant. So F of g is 10 times 9.8. So doing our calculator is 98 newtons, or you could do that in your head. F of x is F of g sine of theta. So F of x is 98 sine of 30 degrees. So that is 49 newtons. Yep, because sine of 30 is a half. F of n, our normal force, is F of g cos of theta. So it's going to be 98 cos of 30 degrees. I need a calculator for that one. I can't do that in your head. So F of n is 84.87 newtons. Right, now I'm going to make this a bit smaller so we have enough room for other stuff. I'm just going to move that there. I'm going to move that just under it. And move that up here. Right. So obviously we have a force going up the slope and a force going down the slope. So, we need to find our force of friction. So force of friction is 0.5 times by 84.87. So F of F is our force of friction. Force of friction, calculating that, is 42.435 newtons. Alright, now the sum of the forces in the x direction is just going to be the force down the slope minus the force up the slope. So it's going to be this force here minus the force of friction. So I'm just going to rub that out now. So sum of the forces is going to be 49 minus 42.435. Right, so that's going to give us sum of the forces. It's going to be 6.57 newtons. So our net acceleration is going to be the sum of the forces divided by the mass. So it's going to be 6.587 divided by 10. So our acceleration is approximately 0.657 meters per second squared. Alright, so those are some basic inclined planes problems. I'll be probably making a couple more. If you had any questions, leave some in the comments. But thank you so much for watching. I hope you learnt something.